Hello everyone, this is a quick little tutorial on how to use coding in Excel. So I've set up my column headings with the important merge and center buttons, which is in the previous video. And now we're going to do some coding and enter some equations. So this might just be a simple change the distance, measure the time of something to fall. So in this cell, we want the average. So you are going to enter equals average bracket, and then you're going to click and drag across, highlighting B5 through to D5. You then go close bracket, enter, and it gives you this number. Now, if you bring your cursor down into this bottom corner, the cursor changes to a little black cross. If you click and drag, that will send the coding down so that each cell, if you double click on a cell, it tells you it's got the same coding, but it's just been shifted down. Okay. Now, the problem here is we've got some recurring numbers. So we're going to highlight all of our calculated values. And up here, we're going to go decrease decimal. So if we decrease decimals, we can round our numbers, round our numbers so that we've got the same decimal. Sometimes when you enter a number, so for example, if you enter 1.30, it will round it. So obviously we need to make sure that it doesn't automatically round it. So we're going to increase or decrease so that that 3 stays there. And the same for this column here, that 0.8, we're going to increase, decrease so that it stays there. Okay. Next, we might have an equation for acceleration, which we know is maybe a half AT squared. Calculating acceleration, rearranging that would be the square root of 2s. No, it's not. It's 2s on t squared. So in this equation box, we're going to write equals bracket 2 shift 8 2 times. Then we're going to click on the s value, close the bracket, and then divided by bracket this number, which is t, and then we're going to go shift 6 power of 2 close bracket. So that's 2s on t squared. Now, I made these numbers up. They're probably not going to give us any nice value, but we press enter. There is our acceleration. We drag that down. There are our values, and clearly I've made these values up. They are not correct. But same deal, if we use our rule for multiplying and dividing numbers, we have to express to the limiting sig fig. Now, here's the problem. Over here we've got 1 sig fig, and then we change down to 2 sig fig. So you need to be careful with this. The precision of these measurements are all the same, and that's reflected in the decimal places. So over here, it would be acceptable to express these to 2 decimal places. I'm going to round this down to 2 decimal places. Okay. Next, if we had our absolute uncertainty, maybe we want an uncertainty in our displacement. Just for this activity, I'm going to write plus or minus 0.005. Okay. So maybe we want the percentage uncertainty of displacement, and maybe we want percentage uncertainty of time. Now I'm going to merge and center that one. I'll just quickly add some boxes. So we'll do the steps one at a time. You could probably do the total percentage uncertainty. As well. And we'll merge and center that one. And then maybe at the very end we want the absolute uncertainty. Merge and center that one. So this one would be, well, there is no measurement there. So just put a dash. No measurement there, put a dash. No measurement there, put a dash. No measurement there, put a dash. Now for this one, it's going to be equals bracket our scale step divided by the measurement times 100. There's our percentage uncertainty. So we'll drag that down. Okay. Same deal. Well, with error, we use the rule 3 sig fig. So let's just round to 3 sig fig. For time, it's going to be equals bracket the absolute. What's happening up here? Oh, hang on. I've got to figure out what just happened up here. Wrap text. Oop. Why are you doing that? Put a few extra spaces in there for some reason. Here we're going to go equals bracket the absolute uncertainty, which is 0.15 divided by the measurement of the average time times 100. Oh, no, that was 1,000. I made a mistake. Let's double click, go back in, change that. Click, drag that down, and we'll round those to 3 sig fig also. Total percentage uncertainty. Well, our equation was, I'll just write it here, A equals 2s over t squared. So we need the percentage uncertainty for distance plus 2 times the percentage uncertainty for time. Oh, dear me, that's very, very high. Okay, there's our total percentage uncertainty. So again, we'll round that to 3 sig fig. We're nearly there. Next, the absolute uncertainty is where we express the percentage as a decimal and multiply that by the value. So we want to get 89% of 7.1. So there is our percentage uncertainty for acceleration. Pressing enter. That's our plus or minus. Drag that down. Again, now we've got to be careful. We need to express our absolute uncertainty to the same decimal as the measurement. So we need 1 decimal place, 1 decimal place. Okay, and this is nice because you can actually see how the percentage uncertainty decreases. So we're more confident with the measurements of the larger trials or the larger numbers. Now to tidy this up, I'm going to add my grid lines or borders. You'll notice some of them are left justified, so I'm just going to highlight the entire data and just center justify all of the data. You might want to, you could put some slight shading and maybe bold our headings. Widen that box a little bit just so all the text is present. Okay, and we need units for our absolute uncertainty. So I'm just going to space across a bit, go brackets, meters per second, close bracket. So now, I haven't wrapped text. So if we look up in J2, the text has disappeared. So I'm going to click on that box and then we're going up here and we're going to wrap text, and that will automatically put our units on the next line. And so everything looks nice. I might just change this one to average. Okay, and so that is our nice looking table with the heading labeled correctly, with the units, with any absolute errors present. You probably don't need these. What you could do, you can't delete them because that takes the data away, and then now our numbers are saying, hang on, what the hell's going on? So let's just go Control Z, Control Z. What you could do though is you could hide them. So if you highlight G, H, and I, you could go hide. All right, and then you might want to print those out. Okay, so you could just print out columns A through J, but ignoring G, H, and I. If you want to bring them back, easiest way is just to highlight the 2 neighboring columns, right click, unhide. Okay, and they will come back. All right, so hopefully these little tutorials are helping you produce nice looking graphs. See you later.